tough theory on the moon's formation might have no evidence after all. Billions of years ago, so the theory goes, something around the size of Mars smacked into Earth, spewing a whole bunch of dirt into space that eventually coalesced to form the moon. That's the theory. And this is called the giant impact hypothesis, and it gives us a neat explanation for a few curious properties that Earth and the moon have in common, like identical minerals. There's just one problem. According to a new analysis led by planetary scientist Paolo Sossi of the experimental planetology group ETH Zurich in Switzerland, they have absolutely no unambiguous evidence that such a giant impact ever took place. Rocks from the Earth's mantle and the moon are indistinguishable on the basis of every isotopic ratio that tracks the provenance of material in the solar system, Sossi told Science Alert. Because the isotopes of these elements vary widely among planetary materials, where there any trace of an impactor, we would expect to see small differences in their isotopic ratios, yet no such differences between the Earth and the moon have been detected. Hence, we argue that in the event of an impactor, the two bodies must have been perfectly mixed, or the moon must have formed in a different way. That's not to say conclusively that the giant impact did not happen. It's still possible. It's just, well, we can't really assume it did either. How the moon formed may have just fallen back into the realm of mystery again. The evidence available on preprint server ARXIV and currently in press for the 2024 treatise on geochemistry is based on a crucial review of all relevant geophysical and geochemical evidence to date. So if there was no collision, where could the moon have come from? Sossi argues Earth and its large satellites simply formed from the same basic material, removing the need for any introduction of a hypothetical third body. Earth and its moon are unique in the solar system. It's the only system with two large spherical bodies with differentiated cores. The moon is not much smaller than Mercury, and were it floating around on its own, may be considered a planet on its own right. The moon is also thought to have played an important role in helping life evolve. It helps stabilize Earth's spin and generates the tides that help the oceans circulate. Without the orbiting mass of rock, Earth would have been a very different place. Because the moon is both so rare and so important, scientists want to know how it got here. Its origins could shed light on our own story and perhaps help us gauge the likelihood of how often such systems form out there in the wider universe. The giant impact hypothesis is not a bad one. During the early days of the solar system, some 4.5 billion years ago, things were a lot more chaotic. There were way more rocks flying about willy-nilly, which we can ascertain from the craters left behind on the planets and moons that survived. So it's not implausible that a baby Earth got whacked by something large enough to create a cloud of impact debris that formed the moon. The problem Sossi and his team have found after examining the available evidence is that Earth and the moon are two similar elements on Earth, and the moon have ratios of isotopes, different forms of the same atom with varying numbers of neutrons in their nuclei that are identical, and the more we examine, the more we find. Sossi explained, initially this concordance was found only for the isotopes of oxygen, but more recently, since the early 2010s, this has been found to be the case for chromium and titanium, both of which are elements that are concentrated solely in the rocky part of the body. Furthermore, because the isotopes of these elements vary widely among planetary materials, were there any trace of an impactor, we would expect to see small differences in their isotopic ratios, yet no such differences between the Earth and the moon have been detected. This is subsequently also shown to be true for a host of other elements, for example, iron, calcium, molybdenum, etc., making the likelihood that this could have risen through coincidence astronomically small. A recent study has shown that Earth and the moon are also around the same age, or formed very close together around 4.5 billion years ago. Taken together, the evidence suggests that the two bodies formed from the self-same cloud of material. That's not to say that an impact could not have been involved. One model suggests that an impact pulverized the whole kit and caboodle of whatever the baby Earth looked like, producing a donut of material that coalesced into two bodies, Earth and the Moon. The big, giant, but giant impact models often predict small differences in the isotope ratios between Earth and the Moon. Those differences simply do not exist according to existing data, meaning although a giant impact cannot be ruled out, we ought to exclude models that produce results inconsistent with the real geochemical data. Even so, the parameter space is essentially infinite, Saucy said. We just don't know how Earth and the Moon came together from a clump of stardust 4.5 billion years ago. One way to probe it further is to investigate what's inside the Moon, and that's what Saucy and his colleagues are working on. The chemical and isotopic evidence is now sufficiently strong to start questioning the fundamental mechanisms of moon formation, Saucy said. We're also pleased to see how interrelated the geophysical, geochemical, and dynamical constraints can be provided a new holistic view on the formation of the Moon. We're able to communicate on mutual problems across disciplines, which will ultimately help us in finding a solution to this conundrum. The research was can be read on ARXIV, and this is on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.